Hello and welcome to another episode of Earth911's Sustainability in Your Ear. I'm Mitch Ratcliffe, your host, and we are back to have another innovator interview, a conversation about how we can improve our relationship with the planet and make our economy and life more sustainable. And, you know, a modern society is composed of myriad complex systems, materials, and responsibilities. As the recycling system matures, we're seeing the introduction of advanced technology, such as machine vision and robotics that can sort plastic from paper, metal from plastic, and so forth. And that can simplify the recycling process. But it's also still on all of us to send clean recyclables to the right programs in order to handle them correctly. Even as advanced technology can help turn more waste into renewable materials, and the next generation of products that we use, people need to start the recycling process every time. It is on us, folks. It's a partnership with the recycling system. And our guest today is Victor Dewulf. He's the co-founder and CEO of Recycleye, a London-based company that makes machine vision systems and robots capable of separating waste on the high-speed conveyor belts at materials recovery facilities, which we often talk about on the show as MRFs. Recycleye also hosts the largest databank of images for different products and materials that can be used to train computers to recognize waste. And that's an important thing to be able to do because sorting waste is one of the most dangerous jobs in a recycling facility. The results are cleaner, better sorted recyclables, as well as greater transparency about the source of wasteful product and packaging. And all of that can improve how we hold organizations accountable for the waste they create. You can find out more at recycleye.com. Recycleye is recycle with Y-E at the end. It's not recycle with an Y-I. Recycleye.com. Welcome to the show, Victor. How are you today?
Very well. Thanks for having me, Mitch, on Earth911.
Well, a pleasure to have you here to talk about what you're doing. And it is really an interesting project that you've been working on for a number of years. How much waste is in our system today that we're just not able to sort? And what do you project the value of all the materials that your system can start to sort more efficiently might look like? How much can we change the economics of recycling with automation?
Absolutely. So today, not a lot of stuff does get recycled. So worldwide, only 8% of material gets recycled. We do a lot better in OECD nations. So we're around sort of the 40% recycling rate in Europe. I'm less familiar, I'll be honest, with the US figures, but I know you guys are a bit behind us. Overall, today, what can be recycled is mainly what people put in a separate recycling bin. That's the really step number one. If you don't do that, if you put your paper in your mix with your organics, you can forget about doing anything with it because it'll be fully contaminated.
Well, I do have those numbers. According to the Environmental Protection Agency, we recycle about 32% of our material, but there's a lot of other data that suggests it could be as low as 23% or even less. So we have this goal of reaching a 50% recycling rate in the United States by 2030. Can we do that? Do you think that's viable? And how much additional technology will be essential to making that step?
First, yes, I think it's absolutely realistic to achieve it if we put the right resources behind it. The way Recycleye is trying to solve the problem is really recognizing that the stuff that's today not getting recycled is just because it's not economically recyclable.
Right.
And essentially, you need to reach a certain threshold to achieve recyclability of a material. And that threshold is when the cost of sorting of a specific batch is below the value of that material. And our business at Recycleye is very much to change both those sort of axes. The first one, we're reducing the cost of sorting by using artificial intelligence that's able to identify all the different plastics, paper, aluminum cans, and then automation to automatically sort it out, thereby reducing the cost significantly. But we don't stop there. We also look at increasing the value of the sorted material. And the way we do that is increasing the granularity of sorting. So, for example, if you were to mix plastics from other materials, that's worth some money, not so much. If you then go one step further, mix out your PET from your HDPE, that's worth some more. We're really pushing the boundaries of what can be done by, for example, even going towards sorting out food grade versus non-food grade plastics. today, for example, a mix of HDPE, food, non-food mixed together will typically sell only for 500 pounds per ton, because you can't sort of recycle it to make new food grade material. If we can start sorting this out, it can be sold for 2,000 a ton, thereby suddenly changing the economics of recycling and meaning that your HDP is becoming a lot more valuable, and so more people will open recycling facilities.
So tell me how the machine vision works. Is it looking across a much broader spectrum of light than we see in order to make the distinction between, for instance, PET and HDPE?
It does not. So we actually use, one thing we recognized is humans are probably the best sorters out there, and that's why you have so many of them in waste facilities at the quality control step. Our human eyes, you look at an aluminium can and you don't need X-ray vision to understand it's aluminium versus plastic, and you don't need to read the barcode to know that it's a Coca-Cola can versus a Pepsi can. So that's very powerful. And so we're replicating humans' abilities, leveraging what is ultimately a very basic sensor. Compared to lots of other sensors out there, the human eye is quite basic, it just sees visible light. But that has enormous advantages in waste, where we're dealing with super dusty, dirty environments with low maintenance. Having something simple from a hardware perspective is a massive game changer. The real value is obviously the brains we have, which we are able to analyze all those pixels to detect useful information. And that's very much the core of our company, which is developing those algorithms that can then identify the different material types.
So it's simple recognition. And that brings us to the question about your Wastenet database. You have a database of 3 million images of stuff that you have identified, and you can use that to train one of these robots to recognize what's passing by on the line. First off, how long did it take to put that together? And are you continuing to ingest more information to keep up with the changes in products all around us? How do you manage it?
So it took a long time, but I wouldn't say our database is actually our most valuable asset anymore, because we did realize that waste streams are so varied. If you look at an HDP stream in France, in Italy, the US, they're all slightly different. And that actually the value lay in building a semi-autonomous platform that allowed us to generate a database very quickly. Okay. Our first market was the French market, where it took us around 6 months to get enough data to have really good performances on our systems. More recently, we deployed in Italy, and it just took us a week, and thereby, essentially, that's mainly due to all the amazing work our technology teams have done to automate as much of that process as possible. Once we have a good threshold of performance, we essentially, every new detection the system does, it doesn't just tell us this is a PET bottle or a piece of paper, but it gives us a percentage certainty at which it knows that's the case. And whenever there's stuff where it's not sure, like it might tell us, I think that's a PET bottle, but I'm really only 10% sure. Then we flag those images, and these are manually checked by a team that will then make sure they're either added to the database to the relevant class, or a new class is created if it's a completely new type of object.
Okay, so it's human assisted too. I hadn't realized that. Now, once it's in place, the system, how fast can the AI recognize and pick something off the line?
Yeah. So that's where we've done incredible work. AI is hard to run fast because you're looking at quite high resolution images and analyzing every last little pixel in them. Today, we run at 60 frames per second. So every second, it processes all the pixels of 60 images, one after the other.
Looking at the whole line.
Looking at a whole conveyor belt, detecting all the items in quite a commingled image. And in practice, that means that for a belt that typically runs at 0.5 meters per second, we actually detect every item 120 times. So even if we get a few mistakes, on average, we get it right. And so that means our performances can be very, very high. It also means that we can run on belts that run up to 5 meters per second. And that's with new applications we're developing. Essentially, we're collaborating with optical sorter manufacturers to essentially also enable them to have AI systems.
I hadn't really thought about the fact you get so many shots at recognizing the material as it's moving through. That's okay. So a moment ago, you mentioned that you had a PET line, for instance, in France. So that assumes that the material is roughly sorted into a type of material before it's put into the line. Is there a possibility that we could literally rip open all our trash and sort through it more efficiently in the future with this kind of technology? Or is our trash just too contaminated in general to do that?
Yeah. So the line I'm referring to in France, this is at the back end of the MRFs you mentioned earlier.
Been
so
sorting
you have already loads of machines, and then you have a lot of quality control. And so you have a PT line, an aluminium one, your paper, HDPE, and it's making sure that you go from your 90% purity to your 99% purity to have the best resale value. But there is another, with this new technology, there are two options. One, we can optimize the current market, but we can also reinvent the way the market works. And we're doing that with one client in France, where instead of building a very large facility far outside your city center where you need loads of trucks to go back and forth and they get blocked in traffic or create the traffic themselves, we're essentially developing a project where we sort of thought that through again, where we realized if you can have a few robotic units in a row, they're a lot more flexible. So each unit can actually sort multiple material types into separate bins. Because they're fully automated, we can run 24/7. And so the facility can be sort of half the size for the same throughput and much lower cost. We're now placing that facility within the inner city center of Paris. So it's reducing all the transportation costs. You no longer need to bring it outside. Land lease is also significantly cheaper because we can start looking at putting it to existing bin storage rooms of places like airports, train stations that already have those spaces.
Oh, so okay, really highly distributed. You don't need a MRF necessarily. You could actually start to sort material where it exists in large volumes.
That's one of the projects we're looking into. Yeah, what we're currently working on. Absolutely. Yeah.
Okay, that's fascinating. Now, can it also recognize contamination? Can it say, I know that's PET, but it's got gunk on it?
Currently, we don't currently do that. So because it's PET bottle is a PET bottle, even if there's a bit of stuff on it, you still want to send it through processing because it's all going to go through a wash line anyways before it gets repelletized. Theoretically, we could teach it to detect dirty PET versus clean PET, but we haven't yet received a request from our clients to do that.
So is the Wastenet database open and accessible to anybody? Is this something that you are working to create an industry standard around?
So we're working to create an industry standard, particularly around the classification of waste, because it very quickly gets complex. Or you're speaking about a bottle versus a can versus stuff like that. But then even within definitions of color, we have endless arguments with clients on where is the difference between a PET transparent versus PET blue.
Yeah.
And everybody has their own sort of brand of bottle of this is the one that sort of marks the difference. So that's the main challenge, and where we're collaborating with a lot of industrial players. We are open sourcing the Wastenet database, but mainly for academic purposes. So it's universities that are working with us, which are getting this huge amount of data that they can suddenly play with to develop new algorithms or new technologies.
Interesting. That's the approach we take at Earth911. Our database is available for research use, but we charge for commercial use. So I understand that how you're working that out. Now, let me ask this: what other secrets does our waste contain? Does the Wastenet data perhaps give us the ability to provide feedback to manufacturers about how they can improve their packaging or reduce the use of packaging based on what we're seeing come back to the MRF at the end of the life cycle? Yeah.
So one of the things we can see is, I've obviously talked about all those nice clean lines, but in every MRF, you also have what's called a residual line, which is all the gunk from the facility that nobody wants, which is pretty much going to go to landfill. And we're starting to install some of our vision systems on those lines and to identify, what is the stuff that actually isn't being recyclable. Mm-hmm. Manufacturers can do a whole lot of stuff to make products significantly easier to recycle. From very simple, people that do brown board and have, say, a little plastic window in the box to see the product inside. That's horrendous because it's not plastic, but it's not gray board, so it'll end up in residual. More recently, I think it's PepsiCo that took the great decision of stopping to manufacture green bottles. which was sort of their iconic trademark, and have gone to transparent bottles. That again makes a big difference because a lot of smaller plants don't necessarily have one extra machine to then sort out your PET transparent to PET green. So the PET green goes into residual because if it goes into your PET transparent, you essentially reduce the value of your nice clean PET transparent that can sell for much higher prices than the green stuff because you can do whatever color you want afterwards. If you have transparent and green, you can only do green.
The funny thing is for consumers, the idea that green and clear are different is just, it seems sort of absurd. It's chemically roughly, it's the same except for the hue. And this is one of the sources of confusion we get a lot of questions about. How do you envision the experience of being a curbside recycler changing because we put so much more automation downstream from you? Is it going to be simpler, or do we still need to be, or even better at the sorting we do before we put stuff into the bin? Does it get easier?
Yeah, I think it's definitely going to get better. Consumers will still need to sort out their recyclables into a separate recycling bin. Sure. And that's really the main step that needs to happen. I believe the industry will always mold itself to whatever collection scheme is being put in place. Some new legislation, I think, is damaging some of that. So a lot of European countries are currently looking at implementing deposit return schemes, and some US states as well, which I think disturbs that equilibrium that a lot of facilities are working towards, whereby essentially deposit return schemes, just to give some context, are schemes where we're now adding sort of reverse vending machines inside shops, and people bring back their PET bottles and their aluminum cans, which is great for the recycling rates of PET bottles and aluminum cans, but ignores everything else. And actually, if you look at the revenue of a recycler, most of it comes from the PET bottles and the aluminum cans, because there's what is worth. And now we're sort of create separate recovery streams and sort of splitting our removal chains into stuff that goes through stores and then stuff that goes through the MRF, with no obvious reason as to why we're doing PET bottle and aluminum. Why are we not putting milk bottles back in the store as well? It's sort of, it's starting to split that stream. I think the best thing industry can do and policy is just maintain sort of the long-term vision as clearly as possible without changing it. Because a new facility is massive investments, and it's going to have a 20-year lifespan. So if you sort of change every 10 years your strategy, you're constantly rebuilding facilities for different waste streams. And that means that recycling doesn't work.
Again, that sounds challenging to people, the idea that because of the deposit scheme is creating another channel of clean waste, that it hurts the MRF. But the MRF is the sort of the comprehensive approach to our waste. And so could we imagine using additional technology to enable deposit systems to pay you back for putting that material into the bin and therefore headed to the MRF? Are there, and this is something we talked about in the past, thinking of this as a transparency issue rather than just a process issue.
Yeah.
If we can identify everything and track everything, could we make it possible in 10 years that when you put things in your bin, you get money back for having put things in the bin?
I think you can do it even now.
Really?
So it is very new technology, but you do have, so in Ireland, for example, they're very much considering implementing deposit return, but a digital deposit return scheme, whereby instead of having loads of the reverse vending machines that people don't like for many reasons, as you say, it creates a second split, but also it's unfair to smaller shop owners, because typically they're going to end up in large supermarkets, and that means people will go back there to bring bottles, and all the smaller shop owners don't necessarily have the space to put in massive machines inside their shop. So instead, digital deposit return is the idea whereby every new item being manufactured in the country has a unique QR code rather than the generic barcode per SKU. So it's a unique per item QR code. And then another QR code on every bin. And whenever you then put something in a bin, you scan the QR code of the bin and you scan your unique QR code. But the reason it needs to be unique is to prevent fraud.
Sure.
Because you don't want people then to obviously scan 5 times the same product. So you can only scan it once. You do assume that the person then throws it into the bin rather than litters it onto the ground. But practically, there'd be almost no incentive litter it if you're by next to a bin to put it away. So that's one way people are looking at it. And then we're looking at using Recycleye systems to then have an extra step to confirm that indeed that material has arrived in the material recovery facility.
And because you have the individual ID, like the serial number on a bill, a currency, you know that's the item. It was scanned here at home. Now we see it in the MRF, and you could say, here's your 5 cents back.
Absolutely. And if you're interested, you should check out a company called CryptoCycle or Reward for Waste. They've started doing trials recently in a few municipalities in Ireland.
We'll have to check those out. So we often end these conversations by asking for a prediction about what the world will look like in 2030 and 2040. What is the recycling system going to look like 10 years from now and 20 years? How do you, as you look ahead at your career, think about the evolution of the industry that you're in?
Yeah, I hope it'll be one where all operational actions are fully automated by machines, and all strategic decision-making is also enabled by data. But I mean, are we building a new facility in this place because we have the lack of throughput, or how much HDP food grade do we have? Could we create a sort of food grade facility? Whilst today a lot of the new sites aren't that efficient because it's often local municipality based, and so some local municipalities will have their own MRF, even though maybe 2 municipalities next door you have another MRF that's only running at half capacity.
Right.
So I would hope it becomes more privatized in some sense. That will definitely drive some efficiencies. Yet the right regulations do need to be put in place by governments in terms of, for example, package legislation.
Do you imagine, we talked about the distributed capability a little while ago. Do you imagine there's a need for policy to encourage large facilities like a sports stadium or a large office building to have a sorting capability on site? Would it be worthwhile to incent that?
I think it would be. Obviously, it's on a case-by-case basis. So if you have a massive facility already next to a big sports stadiums, then yes, there wouldn't be much of a point building the one next door. But I think there's one thing is changing is the ability. Historically, a lot of the people are focused on just building mega facilities.
Yeah.
But that's because the technology we had prior to AI and sort of targeted sorting was what I call non-targeted sorting, which is technology that doesn't actually know what it's sorting. So it's going to be stuff like trommels that are just going to sort of shake stuff by size. It's going to be your ballistic separators. It's going to be your eddy current. Each one of those modules only sorts out one material. With the stuff like optical sorters and robots, each module can sort out as many materials as you want. You can reconfigure them, and it makes a much more flexible site. So you can have very efficient small sites that can run 24/7, that you can even run in several batches. So if you do want to do higher granular stuff, you can just save a batch and then rerun it at night. And it makes for a much more efficient use of an asset, much closer to the waste, to where the waste is being generated. Because ultimately, the second biggest cost of waste management is transport. It's right. Large volumes of stuff that ultimately aren't worth that much per ton. So it's really important to try and reduce the transportation on it.
Well, and going all the way back to what you said about balancing the cost and the benefit of recycling at the beginning of the conversation, it's about increasing our ability to measure, getting closer to the source so that we can also project the future stream, which makes the economics work better, and engaging people in that first important step to put it into the right stream to begin with. And then we potentially have a very efficient recycling system. Okay, now I can see how we can get to 50%. Thank you. That actually is kind of encouraging. How can our listeners keep up with what Recycleye is doing?
Absolutely. Well, we have a fantastic marketing team that constantly put loads of information out there. So check out our LinkedIn. That's perhaps the most active place we share. We have a news section on our website where we release all of our major milestones. We also host a few webinars. We in fact had one yesterday talking through the experience of one of our customers and the new sort of data that they're able to leverage that the AI is also bringing to them. So yeah, that's the best way. Or reach out directly to us to our email of hello@recyclaye.com.
Well, Victor, I want to thank you very much for taking time to talk with us today.
Well, Mitch, thank you very much for having me.
We've been talking with Victor Dewulf. He's the co-founder and CEO of Recycleye, and you can find out more at recyclaeye.com. Recycleye is not spelled like recycle and I, but recycle and I combined with one E between the L and the Y, recyclaeye.com. This is Earth911, Sustainability in Your Ear. And of course, we're going to be back with another innovator interview like this one. I hope that you take a few minutes to listen carefully to what Victor talked about, because we're describing a potential future in which we can all participate in collecting a lot more and potentially create a lot of revenue at the bottom of the economy that incents people to participate in that process. Or if they can't do so because they don't find it convenient, that somebody else will find profit in doing so. Now, we have to do that in a way that's just and equitable, not to create a caste of people who are picking our trash, but there are ways using technology to streamline this entire process to make it both more convenient and fair, as well as incredibly successful. If we can get to 50% recycling rates, which would put us in the top 15 in the world, we're nowhere near close right now, we're in the low 20s. The United States can start to take a leadership role in the restoration of the planet and the reduction of the environmental impact of our economy. We're going to be back soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.